Alright, the last part of section 2, graphing simple rational functions, is another rational function. So you got to pay attention to a lot of equations this chapter. When you see something like this, ax plus b over cx plus d, it has a certain characteristics to it. So we can find the vertical asymptote of this one. So that's part 1. Vertical asymptote is when the bottom, the denominator, is equal to 0. So as soon as you see this, you're like, okay, set this equal to 0 and you'll find your vertical asymptote. In the end, your vertical asymptote is always x equals some number. Okay? Just put a box here. So if you were solving for x, you'd get, x equals some number. So you write the vertical asymptote, x equals something. X equals 3, x equals -2, whatever it is. Next one, how do you find the horizontal asymptote? It's always this. It's y equals. So x equals is this way, vertical asymptote. Horizontal asymptote is this way, y equals. All you do is take a and you divide it by c. Where does a and c come from? Right here. Ax. So the one beside the x divided by the c. Okay, so whatever those two numbers are, divide, and you have y equals some number. Okay, so there you go. That's how you find your asymptotes. How do you find the coordinates? Once again, type this in your calculator. Oh, didn't mean to write that. Type that in your calculator and find your table. Plot your points, and you'll see it's still going to be a hyperbola. So it'll still look like something like this, unless it's negative maybe up top. It'll be in the other quadrants, but you find your coordinates, you draw your branch, and then you could find domain and range too. Remember, domain and range depend on your asymptotes. So it's all real numbers except whatever this vertical asymptote is. The range is all real numbers except whatever this is. Y equals whatever number. Okay? So let's try one quick and then see what happens. Let's see. Nope, not that one. Here we go. So, example 3. Last one. There is one more, but I'm just going to go up to example 3. It says graph this. So as soon as I see this, I'm thinking, alright, which one is it? Is it y equals a over x? No. Is it the translated one? No. It's this one here. Ax plus b, cx plus d. And then I think of my characteristics. How do I find the asymptotes? Okay? Vertical asymptote, VA, is all you have to do is set the denominator equal to 0. So x minus 3 equals 0, which means x equals 3. So, there you go. Vertical asymptote. X equals 3. How do you find your horizontal asymptote? You take your y equals a over c. So what is a in this case? 2. What is c in this case? It's not x. It's not -3. It's 1. cx. Alright, so 2 over 1. Y equals 2 over 1, which is y equals 2. Don't just put 2, put y equals 2. It's a line. Alright, that's a line. Y equals 2. That's a line. X equals 3. Alright, there's your asymptotes. So you could draw a quick sketch. X equals 3 is 1, 2, 3. Draw one here. Y equals 2, 1, 2. There's a horizontal asymptote here. And now it splits it up into 4. Kind of like 4 new quadrants. Let's see, it's positive up top, so it's going to look something like this. And something like something like that, rough sketch. Okay? Now, that's the graph. You can do better, but go to your calculator, get your table. How do you find domain and range? I tell you the trick. Domain, I kind of said this before. It's everything, all real. There's going to be an exception. Except, well, what can't x be down here? X can be 3. It's always the vertical asymptote. All real except the vertical asymptote, which is 3. Your range, once again, this is easy points. Range is all real except your horizontal asymptote, which is 2. So all real except 2. There you go. That's how you find domain of range. Real simple. Okay, so there's three types of graphs you have to know. Y equals A over X, Y equals A over X minus H plus K, the translated one. In the last one we just did here, AX plus B over CX plus D. Know how to do each one of those, find domain of range. Okay, that's section 2.